Hi, this is my video number 11, yeah, number 11 for advanced calculus. In this video I'll talk on the sequence of a real number. The sequence of real number. Sequence of real numbers. So what is a sequence of real numbers? Just to give you a brief introduction for the beginning, if you have a set of sequence numbers, u1, u2, u3, and so on, okay? And up to un and so on. And we use this. U1 we call it as first term. Right? U1 is a first term, and U2 as a second terms, up to UN second term, and so on and so forth. Yeah? U2 and UN is n terms. We denote the sequence number. Okay, we denote the sequence number as un, alright, where n from 1 to infinity. This means we have this kind of sequence, u1, u2, un, u2 up to un, and so on. Okay, that's a sequence. Or in short, we can just write un. So this means this is a sequence number where the element inside there is u1, u2, u3 up to n and so on. So this is the basic notation that we use for the sequence. Okay. Now let me give you some example of the sequence. Example. If say un, we have un is 2n minus 1, so it means we have this sequence, we have that sequence, number 1. Number 2, if say we have that sequence, okay. So if you look at that closely, I might give you another example. Let's say I have another example is minus 1 to the n. Yeah, just minus 1 to the n. See, I have this example. Okay, so if you list down the element of those sequence, what we can see here is this is 1, 3, 5, and so on, up to the n terms, to n minus 1, and so on. Yeah, and this one, say we have 1 over 2, 1 over 4, and so on, 1 over n, so on. And this one, so when n equal to 1, so we have when n equal to 1, so minus 1, 1, minus 1, minus 1, n, so on. Okay, so these 3 examples, if we can plot each of these, okay, or sketch the plot, we sketch of it. For sequence example number 1 here, we have remember that the n must be what we say natural number, 1, 2, 3, 4, 5. We cannot have 1.1, 1.2, 1.3, 1.5. We cannot have that. We must n is a natural number. So which means we have n is 1, 2, 3 and so on. This is n. This is the sequence. So for n equal to 1, so we have 1, let's say there. For 2 we have 3. For 3 we have 5. For 5 we have and so on. For 4 we have and so on. Alright? So this is a sequence number. Don't put a line. Don't put a line, because if you put a line, which means we have n equal to 0.1, 0.2, whereas in this case n must be a natural number, 1, 2, 3, 4, 5, 6, number that we use for counting. Okay, this is for the case A, or for the case 1. For the case B, for the second case, you look at those. So we have 1, 2, 3, 4 and so on. So for 1, n equal to 1, say let's say 1 is here, so we have 1 there, and then 2 half here. For 3 we have 1 over save here and so on. So you can see this thing approaching 0. It will not cross line x axis. Okay, and then for example number 3, we have something like 1, -1, 2, +1, -1, +1, -1, +1. Okay, this is example of the, if you plot this thing and so on. Okay, so if you look at this first example here, we can see clearly that as n goes to infinity, this sequence growing, getting bigger and bigger and bigger. Okay, so as n goes to infinity, we can see that those 2n minus 1 goes to infinity as well. Alright, so in this case we call that our sequence is increasing. We call it increasing. And one more term that we use, increasing without bound. So if you look at this sequence will keep growing, will keep bigger, okay, bigger and bigger and bigger. The bigger n you choose, the bigger the sequence you got. Alright, so now you look at this sequence here, the second example. So if we increase n, okay, what happened to this sequence is getting smaller and smaller and smaller and smaller. Alright, so in this case we call it decreasing sequence. Alright, we call it decreasing sequence. And on top of that, we can see that this sequence will not goes beyond that x-axis. So it's like a bound there. So in this case we call it, this kind of sequence is decreasing and bounded. Okay. Alright, so those two examples. What about this example? Here, this is 1, this is -1 here. You can see this for this example, as we increase n, those sequence will not exceed 1 and will not smaller than -1. In fact, it's in between. Alright? The sequence oscillates between -1 and 1, -1 and 1. So in this case, we call it as a oscillating sequence. Oscillating sequence. And it is bounded. It is bounded. Now, if you look at again these three examples, for the first case, it's increase, alright, and no bound. Increasing and no bound. For this case, decreasing and bounded. For this case, it's bounded, but it's oscillate. Alright, and for this case, for the first example here, is increase, unbounded. So we call this as a divergence sequence. Divergence sequence. Okay. In this case, we say because it's decreased and bounded. Okay, bounded. For this case, we call it this sequence or convergence sequence. Convergence sequence. Okay. We say converge when this sequence, when n increase, this sequence converges to a certain value. For this case, for this particular case, each approaches 0. It's not equal to 0, but very close to 0. So you can look at the sequence 1 over n, 1 over n. You can choose n big enough, let's say 1,000 or 1 million. Okay, 1,000 or 1 million, and it's getting smaller, but it's not equal to 0, but very close to 0. Alright. For the third case here, it's not converge. This is not convergence. Not converge. Okay, not converge. Because as we increase n, the sequence keep on oscillates between -1 and 1. It's not approaching any particular value. Okay, so we must get familiar with this kind of sequence. So this kind of terminology. We have increase, diverge, decrease, converge, bounded, and so on. But this is not the only thing we have. Increase doesn't mean it's converge. It doesn't mean it's diverge. We also have the sequence like this. For example, I just give you a plot. For example, if you have this sequence like this, okay, this sequence increase, but bounded because it has a bound there. Okay, I can also have sequence like this. I can also have sequence like this. In this case, it's decrease and diverge because it doesn't approach any particular value. Okay, so I've given you some quite detailed example there for the each of those cases. Now, okay. So having known the convergence, the properties of those sequence. All right, we have either increasing or decreasing, converge or diverge or oscillates. Yeah. So now let me give a definition of what we call as a bounded sequence. What is bounded? What is boundedness? Okay, bounded. Bounded sequence. Okay. Definition, we say a sequence Un is bounded, and the sequence Un is bounded if there exists a positive number m such that positive number m such that the absolute value of Un less than equal to m for all n 1, 2 and so on. Okay, so this is the definition of bounded sequence. For example, if we have the sequence that I mentioned earlier, -1 to the n, so if we take the magnitude of that, or the absolute value of those n, definitely this value will not getting bigger than 1. Alright, so you can see here, if n sorry, it should be here. When n is odd, you got -1. N is even, you got you got +1. So this is our m. Yeah, this is our m according to this definition. So there exists a positive number m such that this absolute value of those less than that number. So in this case, we say this sequence bounded. Okay, so in this case we say n is bounded. Okay, it's not converged but bounded. Okay, other example. If you consider this sequence, that sequence. So if you take the absolute of those, that, okay, definitely this less than 1. Definitely is less than 1. So therefore again this is bounded. And other sequence. Another example, give you example so that you can see this clearly. -1 n plus 1 over n. That sequence. Again, if you take the absolute of those, we have -1 n plus 1 over n. Alright. This again less than 1. So again this sequence bounded. So all the example here, you can see this sequence, all the sequence are bounded. But what about the unbounded sequence? We call it unbounded. So look at this example. If you have this sequence, we have 2n minus 1 in this case. If you take the absolute value of those and you try to find m in such a way that this is less than m, you cannot find it. You will not able to find it. So that's why we call it is unbounded. Okay. Okay. Let me give you further example. How can we determine, or how can we find the bound m for sequence? Okay. Example, if you consider this sequence, n squared plus 6 over n cubed plus 1, that sequence. Okay, so if you take the absolute value of this, we have n squared plus 6 over n cubed plus 1. For that sequence, because this is n always positive, in this case, we don't have any negative terms. It's all positive, right? So I can just write this. This is just equal to n squared plus 1 plus 6 over n cubed plus, n cubed plus 1. Okay, n cubed plus 1. Okay, so it is obvious from this case, if we decrease the numerator, right, increase the numerator, because what we want is the right hand side is bigger than left hand side. This is the left hand side. Now this is the right hand side. We need this symbol less than. So in order to do that, we need to increase the numerator. So which means if I write this n squared plus 7 over n3 plus 1, this is true. Correct? It is true. Because n squared plus 7 definitely greater than n squared plus 6. I can also write this n squared plus 7 over n cubed. This is also true, because if the numerator smaller than the previous one, so this is the right hand side should be bigger than that one. Okay, and again I can increase the numerator. I can increase the n squared plus 7 and so on. I can increase this. Okay, I can have up to n squared plus n over n cubed and so on. Up to, I can have n squared plus n squared over n cubed, and this is 2n squared over n cubed. You cancel out those, so you have this is 2 over n. This is definitely less than equal to 2 for n equal to 1, 2 and so on. So in this case, our m bound for the sequence is 2. So therefore that sequence n squared plus 6 over n cubed plus 1 is bounded. Okay. Other sequence, I give you many examples here. Other sequence, if you have 1 over 2 plus 1 over 2 squared plus 1 over 2 cubed plus 1 over 2n. Can you list down this sequence? Can you list down the sequence? For this what we have? If you list down the sequence, we have when n equal to 1 plus 1, 7. When n equal to 1 plus 2, so we have 2. Alright? If n equal to 2 to the 2, 4 plus 6, so we got 10. Down there 2 to the 3, so you go 8 over plus 1, so you get 9. You can find this. When 3 to, so we got 9, 15, 3, 27, 28. And so on. Right. What about this? What about this sequence? Can you list them down? Can you read it? So if you list this, I show you. When n equal to 1, we have 1 over 2. When n equal to 2, we have 1 over 2 plus 1 over 2. When n equal to 3, we have 1 over 2 plus 1 over 2, 2 plus 1 over 2, 3. And so on. Up to n terms. Up to m terms, we have 1 over 2 plus 1 over 2, 2 plus 1 over 2, 3 plus 1 over 2n and so on. That's the sequence. Okay. Does it bounded? Well, we can find m. You can try that. You take the absolute value of those. We have 1 over 2 plus 1 over 2, 2 plus 1 over 2, 3 plus 1 over 2n. This is nothing but the geometric series. Alright, it's a geometric series. So in the geometric series, so what thing you need to find? We need to find the what we call that A and R. Okay, so we have here, this is what? We have 1 over 2. Okay, 1 over 1 minus 1 over 2 to n, 1 minus r to n, over 1 minus 1 over 2. So you can solve this out. Okay, you can solve that out. You can simplify that. Yeah? That will give you 1 minus 1 over 2 to the n. So definitely this is 1 minus 2 to the n. This is less than 1. So this is our m. So therefore this sequence again bounded. You might want to ask me how to get this from here to here. All right, from here to here. As I said, this is the geometric series. Geometric series. Well, you can look at in the notes, school notes. You can find this thing. All right. We have our first term is A, which is half. We have our R is half. How to get this? That's un divide un minus 1. So you can find this. So 1 over 2 to 2 divide 1 over 2. So you get half. And so on. And the if you sum up this thing up to n terms, we have what? A 1 minus r to the n over 1 minus r. That's the formula. So we use this formula to get that. Our A is half, 1 minus, this is half to the n. So we got that. And 1 over half. 1 minus half. So 1 minus half. So we got those things. Okay. I have one more question. Let's say if you have the sequence in this form, u1 equal to 0, un in term of un equal to square root of 2 plus un minus 1 for n greater than equal to. Okay. The question is, does un bounded? I put big question mark there. I want you to do this. Try to think. How can you show that sequence bounded. All right, and in your notes there are many exercises or activity that you can do, so please do that. You can always ask me by WhatsApp, or you can leave a comment in the comment. Yeah. All right, so I think I stop there for this video. Okay, bye bye.